Hello everybody, welcome back to Isolate DWF repair video. We have another C64 in a bread bin case, which is not working, I guess. But first of all, I need to open this one because when moving it feels like something is rattling inside. And anyway, it's always a good idea to open an unknown machine and see what's inside before trying to power it up. So let's see what's inside. Okay, turns out it was a good idea to open it. There was a plastic standoff that holds the screw that keep the keyboard half screwed in. And there was also a screw floating around. This could cause a short somewhere, so it was a good idea to open it. This machine has some problems, mechanical problems of course. At this stage there is a broken hinge here. Also, an obvious problem in this machine is this 6522, which is in place of a 6526. There should be two 6526 in this machine and a C64 anyway. And someone replaced the 6526 with a 22, which is used on the 20, 1541s and so on. Fortunately, the pinout is almost identical, so I don't think it damaged something circuit-wise or damaged it itself. It was good. But before beginning, I have to remove this one. So we're ready to power on the board and check the two onboard regulators. This is always the first thing to do. This is a 12-volt regulator on this board. This is 5 volt. So let's power on and see what happens. Of course, black screen. Let's check the 12-volt regulator output, which is 11.7 volts, which is okay. And the 5-volt regulator output, which, whoa, 7.7. Let's power it down quickly. 7.7. No, that must be bad. Okay, fortunately I always remove the seed chip out of the boards I'm repairing, because it's not needed anyway when troubleshooting. But now I will remove also the VIC2 chip and the clock generator chip and test again the regulator, and if it's still showing 7.7 volts, this will be changed. Okay, this is not a lucky machine. Turns out this is a 6567, which is the NTSC VIC2. It was covered with the thermal paste, so I didn't notice. But the board is obviously PAL, and the modulator is PAL too. So this must be a really sad Frankenstein board. Let's see what I can do. So let's cut some footage, since this video is going to last quite a bit anyway. Testing the 5 volts regulator without the VIC chip and the 8701 clock generator gave always about 7.8 volts. So I've just replaced it with a matching brand and date code as the 7812 besides it. The bad part had its legs cut and discarded. I'd say this is a rare failure mode of these kind of regulators. However, now the internal 5 volts regulator is spot on and we can go back to the troubleshooting. So it's time to test without the big chip, only the clock generator chip. This looks good. But this other clock, no, missing. So it's a good occasion to try the replacement chip that Jeff sent to me recently, and this should work. Let's verify. Power on. color clock here. Now pin 6. This is the dot clock and it works, of course. So now I installed the one of my spare, well, this is the last spare actually, 6569. And see what happens. It is just a black screen as expected. Okay, first thing to check is the reset signal on pin 40 of the 6510. Stays low, then goes high, so it's okay. And next thing is pin 39, which should have 1 MHz, well, a bit less than 1 MHz since it's PAL. And it has the signal, of course, because this is coming from the VIC chip, which is good. Now next thing to check on a stack machine is the data bus of the processor. On a 6510 we have from pin 37 to pin 30, of course, so 40, 39, 38, 37. That's not good, as blips, too low. 36, same. 35, same thing. 34, same thing. Now since all the chips are socketed and I know this one is good, and on the data bus there are the ROMs, of course, all the RAMs and all the CIA. This one was missing, there was a 6522 in its place, and without all the ROMs we still have data bus conflicts. As you can see, two low signal. So it remains the ROMs, it remains the RAMs or this other 6526, which I'm going to remove now. And now, without the 6526, the bus look normal. So, another bad chip. Yeah, definitely. Just for, I checked the enable on pin 23, which is this one, and it's always high. So it's not even that it's selected all the time, it's just bad. Too bad. So now I placed it to 6526 that are marginal, but should allow the machine to boot. And the situation is this one. Which means probably the basic ROM. At least that's the likely problem that goes on this empty screen. I tried to swap these two, but it's always the same, so I don't think they are the 6526, and I don't have a spare basic ROM, but I can test this one into EEPROM programmer and see if it reads correctly, maybe. Again, bad news. The basic ROM and kernel ROM do not verify correctly against a load dump. They are both bad. However, the character generator ROM works fine. The worst thing, in my opinion, is that all the three ROMs are not the ones fitted originally in this motherboard. That's because this motherboard comes with socket installed from the factory, as the solder joints are looking untouched. Plus, the sockets are the typical low quality used by Commodore at the time. All the ROMs I've found installed, however, have been clearly desoldered and pulled from other boards because they have trimmed short pins, as you can see, and have still thin residues on the pins. Here you can see by comparison a ROM with untrimmed and unsoldered pins, like the ones installed on socketed main boards. So, 2 more custom chips in this C64 board are wrong or failed, but let's continue in this troubleshooting. So the situation at the moment is this. This is one of my spare. This also is one of my spare. The original was working anyway, but was a pull, and the pins were not making good contact always in the socket, so I decided to put a spare also here, even if the original is working. And that was not working, but I don't have a spare original, so I just used one of my adapters, and this is the basic. And the situation now is this. So the machine boots, but there is no the correct amount of memory which is to be expected because of the Macron technology, the RAMs. And another issue is that I don't have a cursor, but that's because there is no CIA on U1. So let's address the memory problem now. I have to mention that I also had to replace the PLA with a Soviet PLA newly programmed, because the original one, which is a pull and has thin residues on the pins too, get warm and makes just a black screen when warm. So this one failed too. And if anyone is guessing, if we use the original seed on this machine, with the original, with the one I found here, I mean, guess what? We get the black screen. So even the seed is shot. Now to try to solve the RAM problem, I'm trying piggybacking a good RAM chip over each of the original RAM chips, and when piggybacking on this one, this one, this one, and this one, the 3 bytes count didn't change. But when I piggyback this chip, here what we have. Yep, we have the correct amount now. So let me remove this chip and install the new one. Now let's see what happens when we power on. Oh, it didn't solve. No, that must be, well, coincidence. That was good. So let's try to find the bad one. So this simple program will just copy a ROM segment to a RAM segment and then compare again what is read from RAM with what is read from ROM. Any error will be displayed. Okay, I have some clue. If I write this number on this location 53094, what I get is the number I write plus 1. That means bit number 0 is stuck in this location. Let's try with 2 and see what we get. We get the number 3. Just remove the previous number. Yeah, 3. So for example, if I write 4, I should get 5. Yeah, means bit number 0 is bad. Now, an off by 1 error means we have a problem on the data bit number 0. If we look at the schematic, bit 0 goes to RAM chip U21. Let's remember that U21 was one of the RAM chip that I tested with a piggyback, and that had absolutely no effect. Instead, I've got the correct amount of free bytes when piggybacking U12. I believe the old U12 was just good, but for some reasons the bad U21 decided to behave for a moment. So when we try piggybacking on RAM chips, always power cycle 2 or 3 times before concluding that we identified a bad chip. Now I'll substitute U21 and see what happens. Now we have a new U21. Let's see what happens. Looks good. Now so that solved the problem, but I believe there are still problems with this RAM. Basically, the test seems to start, but as soon as it tests the 0-page RAM, which is the first line printed, it seems to find an error and then restarts again. I've also took the time to write a quick machine language loader to run a 0-page test, since it's almost impossible to test a 0-page directly from BASIC. But the machine language program never found any problem with the RAM. So I couldn't find any problem, no matter how checked in BASIC the RAM. I tried various machine language programs to identify a bad 0-page bit, but that was nothing. So I decided to change the only chip, the original chip I found this motherboard, which was the 6510, with a marginal one that had to substitute from another C64, but it works enough. It allowed me to completely troubleshoot the revision A NTSC motherboard, for example, and guess what? This was not working in some way. This works perfectly, as you can see. Well, at least the test is running since minutes and it doesn't find any problem. So I guess this was a bad collection of bad chips put on purpose, in my opinion, on this motherboard. That had some faults anyway that probably they couldn't fix, and they just replaced all the good chips with the bad ones, all the socketed chips with bad ones, and sold the machine like this. That's my opinion, and I'll try to explain why I'm quite sure about this. So to conclude this videos, these are the chips that I found bad on this C64, excluding the dynamic RAM that I identified and changed, and the 7805. This was all socketed chips, and what I do think it's kind of in a base scam, this one. But because these two were just wrong chips, just to fill the place. This is a 6567 NTSC VIC2, and this is a 6522, which is not useful on a C64. It won't do any harm, but it won't work anyway. Because just for example, port A and B register are swapped between 6522 and 6526, which is the right chip on a C64. So I feel they are just put in place to fill the spot. Also the 6567 was covered, the part number was covered with some silicone grease, which was not necessary because that board had no metallic cover on it. I don't know, I always clean the chips before swapping them, but I don't know, might happen. Then the 2 out of 3 ROMs were bad. These are pulls because of the short pins. One of the ROMs was good also, but also a pull. PLA was marginal, failed hard. This is also a pull. On a socketed board you don't find pulls usually, unless you substitute the chip yourself. So even that, I don't know. This was bad. It's not a pull, but it was bad. So this one may be damaged by the 8 volt, almost 8 volt 7805. Also the original VIC chip may have been damaged by the wrong regulator. Oh, I'm forgetting also seed chip was bad also. This was bad. This could also have been damaged by the 5 volt regulator failing, but this failed too hard. I don't know, this gives a black screen, which is a rare fault on a 6581. I've seen also another time, but it's not very common as a failure. And also the CPU failed in a rather strange way, but it's not good. Some games doesn't start with this. I doubt the tape drive works also with this one, because the fault seems related to the I/O port internal to the CPU. So you may say maybe someone connected a bad power supply to it and all the chips failed, but then why substituting them with bad ones again? And also I don't believe this was a power supply failure because no other TTL chip failed in the motherboard, only the RAM, but the RAM was Micron technology, so I've never found a Micron technology RAM that didn't fail at least 1 or 2 out of 8 chips. So I still believe it was made on purpose, but you know, this is my opinion. I mean, everyone else can have his own opinion. I've never found so full of bad chips C64 board when repairing other boards, so that's my opinion anyway. So I guess when buying untested C64 out of a pay, I would prefer very much the non-socketed main boards. At least I know that on those boards there could be anyone cannot put bad chips on purpose on those boards, so I would avoid a fully socketed main board from now on. So I hope you enjoyed, you find something interesting. I would love to see your comments on anything, and until next time, and thank you for watching.